Yeah, so that's what we're going to talk about. And, if anybody has any questions, I'm going to talk a little bit about eclipses in general, why we have them. And then I'll talk specifically about the one that will be taking place. I keep hitting the wrong button. And I have some resources at the end if you want to know more about where you might go and what you should do and things like that. I have that at the end. And then at the very end, I'll tell you about another few things that will be taking place in the spring sky. So hopefully that will be of some interest. I'm also going to turn on, if anybody has a question, you can ask it in the chat window, or you can just interrupt me. I'm not going to be watching this right now while I present. I'm not going to be watching hands going up. So if somebody sees a hand, just speak up. Okay, so we're going to talk about eclipse viewing. And hypothetically, I'm supposed to know something about this since I've been teaching at Cornell for 41 years, in particular astronomy. So the bottom line is that on Monday, April 8th, in the afternoon here, a total solar eclipse will be visible over a narrow band from Mexico to Newfoundland. And so what I thought we'd do is talk about why eclipses happen and how this particular eclipse might be viewed from different locations in upstate New York. Okay, so hopefully I can get this to start. Okay, here's just a time lapse of what you see when you experience a solar eclipse. The sun goes dark. And I don't know if some of you have seen solar eclipses before. I have, and they're pretty amazing events. And so if we have the chance to do it, I suggest you try to get a view. Here in Ithaca, the eclipse will not be 100%. It will be about 99%. So it will be noticeable, but it's really worth getting in the car and driving 40 miles in order to be in the totality, which is up the other end of the lake or further north. We'll talk about that. Okay, here's another example of what you see when there's a solar eclipse. So the moon moves in front of the sun and blocks out the sunlight. When an eclipse of the sun takes place, the moon is new, and then you see that the sun starts to get uncovered as the moon moves in front of it. Okay. Now, the first thing we have to mention is a really interesting cosmic coincidence, which undoubtedly confused the ancients. And that is, even though the sun is 400 times bigger than the moon, and the moon is 400 times closer to the Earth than the sun is. And so as we view them in the sky, they look to have the same angular size. There is no scientific reason why that should be. It just is. But it is kind of a coincidence. And if we lived on any other planet, either in the solar system or somewhere else, it's unlikely that you'd run across that kind of a coincidence. So it's been an exciting time. There have been 2 solar eclipses, one last year in October and this one in April coming up. We'll talk about the one in October was what we call an annular solar eclipse. The one that we're having in April is called a total solar eclipse. So why do eclipses occur? Well, this is a little animation in the center. This is supposed to be the sun, and this is the Earth, and then the little one is the moon. And the sun is much more massive than the Earth, which is more massive than the moon, and they orbit in a very stable manner over millions, or we say billions of years. And the Earth orbits around the sun and then the moon orbits around the Earth. And it kind of looks weird when you look at it in this projection. It kind of looks like it stops. But the fact that there are these two motions going on, the revolution of the Earth around the sun and the revolution of the moon around the Earth, is what creates the opportunity for us to have eclipses. Okay, so let's understand what's happening, a little bit of geometry. Here's the sun at the center, and here we have the Earth, and here we have the moon. And what's interesting and to keep in mind is that the sense of direction of the moon's orbit around the Earth is the same as the sense of direction of the Earth's orbit around the sun. So another way, the Earth is moving this way, and the moon is also moving in the same direction. And now we have to add on to this diagram, thinking of here's the orbit of the Earth, here's the moon moving around. We also have to turn on the day and the night side, because of course we don't see the moon during the day unless it's sort of somewhat before sunset or somewhat after sunrise. So in this particular case, of course, this is the sunlit side, and this is the nighttime side of the Earth facing away from the sun. And this is the moon. And another interesting fact to keep in mind is when we look at the moon, what we're seeing is reflected sunlight. The moon doesn't shine by itself. It reflects the light off the sun. So in this configuration, we're seeing the moon when it is full. And of course, we only see the full moon at night. So we have to also draw on this or keep in mind that the Earth is also spinning on its axis. The Earth is moving in its orbit around the sun in this direction. The moon is moving in its orbit around the Earth in the same direction. And the Earth is spinning on its axis in the same direction. We can tie those spinning of the Earth on its axis to times. If the Earth is spinning this way, let's say you're a point on the surface of the Earth. At this point where my cursor is, that must be about 6 a.m. It's sunrise. You first start seeing the sun when your spot on the Earth is up here. That's noontime. The sun is directly overhead. Then 6 hours later, the sun sets. This is, of course, changes according to the time of the year, but on the equinoxes, it would be like this. And then at midnight, in this configuration, the moon would be directly overhead, and of course, the sun would be completely below the horizon. So there's a correlation between the phase of the moon, the position in this diagram, and the time of the day. So this is just to remind us, when we don't see any of the reflected sunlight because the moon is over here and the lit side of the moon is therefore facing away from us, we have new moon. Then over time, it grows bigger. We have the quarter moon, and then we have the full moon, and then the moon starts to get smaller or wane and becomes fainter and fainter until we get back to new moon. So if I draw that, again, here we have the sun. And as always, when we draw these diagrams, the actual distances here are much, much bigger than they look. So keep that in mind. Little cartoons, if we wanted to put those cartoons in correct perspective, we'd have to have the sun way out there in the Atlantic Ocean. But here we have the different phases of the moon going from new to waxing crescent. We're in this phase now. We're in this phase now. We're just past full moon. We get waxing crescent first quarter, waxing gibbous full, waning gibbous the third quarter, and waning crescent, and then back to new. So the moon is full over here and new over here when the lit side is facing away from the Earth. And again, those line up. We can also draw on this the time at any location on Earth according to where the sun is and how the Earth lit side makes the daytime and the dark side makes the nighttime. Another thing we have to keep in mind is that although the moon's orbit is almost circular, it's not completely circular. And in fact, this little diagram shows you how slightly elliptical it is. What that means is that sometimes the moon is a little closer to the Earth and other times it's a little further away. When it's close to us, it looks bigger. When it's further away, it looks smaller. So in fact, last weekend, when we had a full moon, it was called a micromoon. And that's because, again, here we're grossly exaggerating the orbit and the orbit's squishiness. But last week, when we had the full moon, the Earth was a little further than average from the moon, so the moon appeared smaller than average. But that's why sometimes last fall we had several supermoons in a row, but this month we happen to have a micromoon. Here is just a picture of the difference. You can actually take images of the moon and you can see this is a supermoon and this is a micromoon. And as we look at them in the sky, the moon will actually be of slightly different size. Okay, so first let's talk about lunar eclipses. And we'll come back in a little while and talk about the fact that there's going to be a not very exciting lunar eclipse in April. But let's just understand what a lunar eclipse is. So a lunar eclipse occurs when the Earth projects a shadow and the moon moves through that shadow. And so here we have the sun, the Earth, and here we have the path of the moon. Shadows get cast by solid objects like the Earth have different parts. They have the deep shadow, or what we call the complete or umbra, or then we have the partial shadow, which we call the penumbra, where some of the rays get through, but not all of them. And then we have the deep shadow. Again, remember that the light that we see from the moon is reflected sunlight. When that moon goes through the Earth's shadow, the sunlight is blocked out. And so we see an eclipse of the moon. So here's another view of what you see. You see the color changing because the camera is adjusting itself. And in fact, there's some scattering of light in the Earth's atmosphere that causes the moon to look red when it goes into the umbra. Okay, now let's talk about solar eclipses. Solar eclipses occur when the moon passes directly in front of the sun, blocking out its view over a small region of the Earth. For this to happen, this is what's going to happen in April, this will occur only at new moon, when the moon goes in front of the sun and the lit side of the moon is facing away from us. A lunar eclipse can occur over a large region of the surface of the Earth. A solar eclipse occurs over a very narrow path of a few hundred miles wide, and it moves very fast as it travels along a path like across North America.
I'm sorry.
So here we have again what we would actually see. The moon is now blocking out the light from the sun so that it doesn't reach us. Okay, so again, another diagram. Here are just some links. If some of you want to look at some things that are a little bit longer than me, here are some links that might be useful, and I can have Cassie or someone send these notes, these links around, these slides around, if anyone cares. Maybe you would like that. So here's the sun, and here's the moon. And again, the moon casts a shadow on the Earth. And you only get a total eclipse if you're inside the umbral part. You get a partial eclipse so that part of the moon's light is blocked out if you're in the outer part, the penumbra. And so we can end up with different kinds of eclipses. We can get a total eclipse, and just the same way that the moon's orbit around the Earth is not perfectly circular, so the moon isn't always at the same distance, and we get micromoons and supermoons. The Earth's orbit, we get the same kind of phenomenon in the case of the solar eclipse. If the moon is a little further away, the same way it was last month when we had the micro full moon, we get what's called an annular eclipse. If it's further away, it's a little smaller. And so it doesn't completely block out the sunlight. The eclipse in October was an annular eclipse, therefore. The moon is smaller, and so it doesn't completely block out the sunlight. A total eclipse is when the moon is at average distance or closer than average, and it really completely blocks out the light from the sun. Then sometimes, as we'll learn, sometimes the moon and the sun and the Earth aren't completely lined up. And then we get what we call a partial eclipse, and we'll talk about that. So again, we have different kinds of eclipses, total eclipses, which occur when the moon is at an average or closer than average distance to us. An annular eclipse when everything is perfectly lined up, but the moon is a little bit further away. And a partial eclipse when the moon blocks out part of the sunlight, but not all of it. So why is it that we don't get eclipses every full moon or every new moon? Well, there's another complication in this picture that we've been talking about, and that is that the Earth orbits around the sun and the moon orbits around the Earth, but the planes of those two orbits aren't exactly lined up. They're not like this, they're kind of like that. And so because of that, we only get eclipses when the orbit of the Earth and the orbit of the moon around the Earth line up. And that happens usually a couple of times a year. The inclination of the two is about 5 degrees. So you only get eclipses a couple of times a year instead of every month. And so again, that leads us to, we have a situation like this. We can have a case where the moon's shadow is too high or it's lined up correctly. In this case, we see an eclipse. In this case, we don't. Here's another example, little video that attempts to show this. So again, the shadow is too high. Comes down, you get an eclipse. Shadow is too low. We get an eclipse. It has to be just right in order for us to get the eclipse. Okay. And here's a little video that shows the eclipse that occurred last year. So this is the annular eclipse. Again, so that you can, I just show you this so that you can see that the path on the Earth is very small. The shadow of the Earth, of the moon projected on the Earth, which is essentially what an eclipse is very small. Okay, I just want to mention another thing, which the ancients actually understood, and that is that we have different motions that are going on. We have the Earth, the moon orbiting around the Earth, and we have the Earth orbiting around the sun, and we have the inclination of the moon's orbit with respect to the Earth's orbit around the sun. And we also have differences in the time from full moon to full moon, and the time from the moon being closest to the Earth to the time the moon is next closest to the Earth in this elliptical orbit. And then we have this lining up. And that's something that's called, that leads us to something called a Saros cycle. And that just means that we'll have a similar configuration of an eclipse. In other words, how it travels across the Earth will reoccur with a period of about 18 years, 11 days, and 8 hours. And it doesn't mean that it lines up perfectly, but another eclipse occurs that has a similar path, offset a little bit. And so you can see here are some eclipses that are occurring around in this time frame where you can see the path is parallel, but offset a little bit. What I find amazing is that this concept of repeating eclipses was known in 700 BC. I certainly only know it because I've read about it. Here's another little animation. If any of you are interested in studying more up about this, you can look at Wikipedia or other sites. It's just, to me, it's just truly impressive that these eclipses reoccur following this period, which we understand, but that it was understood in 700 BC. Okay, so here's the 2017 eclipse, which occurred in North America. Maybe some of you have seen that, and here's the path of that one. It had a greatest eclipse duration of about 2 minutes and 40 seconds. That's another thing. This experience of watching an eclipse that you're going to have is only going to last a few minutes, but it travels across the United States like that. Here's the path of the solar eclipse on October 14th. Again, it was an annular solar eclipse. It traveled down, starting off in Oregon, went over Utah, down into Texas, and then down into South America. Here's just a picture of the Great American Eclipse of October 14th. And you can see that it was an annular eclipse. So the moon starts to, it's going this way. The moon is starting to block out the sunlight. It doesn't ever completely block it out because the moon was too far away, and then it's moved off to the other side and the sun came back. Okay, so now let's talk a little bit about this year's solar eclipse. And again, I've got some links to various websites that you can take a look at yourself. Here's the path. It's going to start down in the Pacific Ocean, cross over Mexico, up through Texas, across Indianapolis and into the Northeast, and then off the Canadian coastline. If we look at that a little more closely, you can see here is the path of totality. That's what you're seeing colored in. Out here in Ithaca, we will see a partial eclipse. which is at about the 99% level. But a total eclipse is a different thing. It won't get as, it will get a little, maybe noticeably dark, but not so much. It'll be easy to see with a small telescope or even glasses, special glasses. Here is the line of totality, and you can see it runs through Buffalo and Rochester. However, we have to warn everyone that the probability of it being clear in upstate New York on April 8th is only about 40%. So we have to hope we have a good day, and it's not a day like today, which was sunny in the morning and then clouded up in the afternoon. Here's just a zoom in on that. But you can see if you have a favorite place, lots of places along the lake over here would be good, or the lake over here. So here's a little bit of information, and again, you can look this up. There are some great websites. This information comes from this eclipse.org. They have a simulator. They can tell you when the eclipse is going to occur, and exactly in many, many cities in the United States. In Ithaca, it's going to be have 99% of the sun blocked, and the maximum point when of darkness will be at 3:23 in the afternoon. Here are some additional resources that you might want to take a look at. One of them is a NASA eclipse page, but New York is getting big into this. And so if you're interested, or you have an idea of where you want to go, if you go to this ilovenewyork.com site, they have links to where are good places to view the eclipse in all sorts of different locations along that band. And so I suggest you want to go take a look at those. Here's just the top of a page from visitingfingerlakes.com that tells you for lots of different towns in the path of totality. It tells you the duration of the totality. So you can see that the closer you go to that center line, the longer the eclipse, and it can vary from being only a minute or so all the way up to 3 minutes and something. But the time is in the afternoon. Okay, let me just finish up, and unless anybody has questions, I'll take questions at the end. One of the reasons that this is exciting is these are looking at eclipses in the future. And very frankly, here's our eclipse of 2024. There isn't going to be another eclipse here that goes through anywhere near here anytime soon. This one, which goes out through the Great Lakes, will be in 2048, which is, you know, quite a ways away for us. We'll be old people then. Okay, let me just finish up, and then I'll come back and answer any questions. Just other things to look out for this spring. In the next few days, if any of you are up before sunrise, the moon will be close to the star Antares. And so you'll see this very red star close to the moon on March 3rd. But the real reason that I wanted to put this up here is I wanted to give you all the link to a website which puts out diagrams like this every Friday. It's associated with Sky and Telescope magazine, and I look at it every Friday for it to tell me what's happening in the sky. We will have a penumbral eclipse of the moon here in Ithaca on March 25th. The bad news is, remember that a penumbral eclipse of the moon is when the Earth goes, the moon goes through the Earth's shadow, and not much happens. It doesn't get very dark. So you should only get up and look at this one if you really think you have binoculars and are in a dark place and are willing to watch for a while. Okay. Again, lunar eclipses. The other thing that's happening is whether the snowman or the groundhog like it or not, whatever, the equinox this year is going to occur on Tuesday, March 19th. That means the beginning of spring for sure. But apparently it's already happened. The groundhog was right this year. Another thing to keep in mind is that we changed to daylight savings time on March 10th. So 10 days from now, we'll be starting to get up when it will be darker, but it will be light in the afternoon. Two other things to look for. Well, one thing in the spring and one thing in the fall is there is a comet which will be at its closest approach to the sun on April 21st, and its closest approach to the Earth on June 2nd. But the best time for us to probably see it here in the Northern Hemisphere is in late March after sunset. And I mention this one because comets often aren't visible to the naked eye. This one is just on the threshold for naked eye visibility and should be visible with a small pair of binoculars in June when it's closest to the Earth. But it has the potential for being naked eye brightness. We can't really predict very well how bright a comet is going to be. And this one is interesting because it's possible that it could be bright enough to see with the naked eye. We'll just have to watch and keep an eye on it. Another comet, which is likely to become very bright, will be visible potentially in the fall. And so we'll have to keep an eye on this one. As I said, again, we don't know exactly what's happening to these comets, whether they have enough material and get close enough to the sun that they get bright. This one is on an orbit that takes it, that travels around the sun with a period of tens of thousands of years. So it hasn't been in close to the sun. And so there's some hope that when it does that, it will really become bright and we'll be able to see it. So I think that was all I wanted to say, but I'm happy to answer some questions about viewing. Oh, there's one other thing. There's one other thing that I wanted to say, and that is if you want to view eclipses, you should get yourself some eclipse glasses. And you can find them on Amazon. They come in packs. Just make sure when you're looking at them, looking them up, that they say they are NASA rated. Then they would be also useful in Ithaca, New York to see the partial eclipse. And I guess one other thing, you do not look at eclipses without sunglasses. The other one is the biggest problem with going to observe an eclipse is there are going to be hundreds of thousands of other people who are going to go observe the eclipse. And so the biggest problem is traffic. And so you should be relaxed about leaving. If you go somewhere to view the eclipse, bring a picnic basket. And after the eclipse, have a nice afternoon tea and wait a couple of hours before you leave. Anybody have any questions?
Is that the third or the eighth? I'm trying to figure out.
The 8th. It's the 8th.
Of March.
Yeah, Carol,
Where
April.
will you be watching the eclipse?
I'm not telling.
Oh. A secret spot.
A sacred spot, but I'm not going to Rochester or Buffalo. I think I'm just going to drive up north into the zone on some untraveled road.
On the farm.
Take my time. I'm going to plan out a route and just go up. I mean, when you get up close to the lake, there are places where you ought to be able to see things. I'm also going to look at the weather forecast. But that's my plan. I don't want to be caught in a lot of traffic, and I have to teach in the morning.
Well, would
Yeah,
a
Mary,
place, would a place like Toganok be okay?
it's not far enough north to see the total eclipse. To go to the
but I
total,
mean, 99% is good enough for me.
yeah, well, then you just need to be actually, Taganic wouldn't be the best place. I'd go up into Lansing, somewhere where you've got a nice view of the sky and there are no trees in the way.
Yeah.
So he would go up to.
You know, and wherever, but just get up where there aren't any trees in the way. There are plenty of places like that, and that's why I'm sort of going to play it by ear.
If he even joins.
But I'm also going to be realistic and realize that, you know, there's some possibility that it will be raining, in which case I will stay home and watch it on TV.
His telescope.
Or snowy.
No. That is not allowed.
And, or.
Jerry, you're not muted. We're hearing everything you say.
Yeah.
Oh, dear.
That's okay, I didn't say anything naughty.
So we can't hear the people asking questions.
Yeah, sure, no, sorry. Where does it say mute?
Well, there,
Oh.
it's Barbara's fault.
So I will send around, I'll send to Cassie or somebody the slides and you can take a look. So my suggestion is get yourself some eclipse glasses, even if you're going to stay in Ithaca. If you want to look at the partial eclipse, you need the eclipse glasses. Look at some of the websites to figure out exactly what the times are, although I have the main ones written down on the slides. And the links are all there. So if you get the slides, you get the links. And then think about how you want to do this. Maybe you want to drive somewhere and stay overnight, in which case, you know, you're planning to have a nice time afterwards and you won't get caught in traffic. Or if you're just planning to drive somewhere, I think you only need to be in a place where there aren't a lot of trees, where you have a good view of the sky. But do be prepared to get in a traffic jam afterwards, because afterwards everyone wants to leave.
Martha, you know, you have been obviously experienced watching eclipse and your advice about the traffic. I mean, is this the sort of thing that we can expect people from all over the country to be here?
Well, yeah, yes, I think the answer is yes. I know a lot of people who have booked B&Bs up in the North Country, for example, or in the Rochester, Buffalo area. The Canadians are going to invade us. So there really are going to be a lot of people who come, and we're not in the total zone, so they will not be coming to Ithaca. But the problem is wherever you go, that's why I said I don't think you have to worry about getting there. But once the eclipse is over, everybody's going to want to leave. And I know this from my sister went to the 2017 eclipse and she found she lives in Omaha. They drove a couple of 100 miles to some place in the middle of nowhere, but it turns out so did everybody else. And I had warned her, so they had taken some picnic stuff, but they decided to leave, and then they got in a traffic jam. And so they got off the highway and went and sat down and had their picnic, and then said afterwards, we know you told us that this would happen, and it did. But if you're prepared for this, you see, and you decide you're not going to be in a rush to leave, and it will be April, so it won't get dark until 8 o'clock at night or 7:30, then you just relax. Book a restaurant for dinner. And besides, it's not that far. You literally really only have to go as far as Geneva.
Right. Right.
Went to the one in 2017 I was in Salem, Oregon. I was living in the Seattle area. It usually took me from Salem to Bainbridge Island, where I live, was usually about 2.5 hours. It took 5 hours that day. And there was a lot but we were expecting it. So we just turned on the radio and car danced all the way back. So people probably thought it was weird, their cars rocking and rolling, but we had a good time, and we just weren't going to let it spoil the whole thing. And it was incredibly cool. It was just, it's not the same seeing a partial. It's really worth it driving up and seeing the total eclipse, because when the lights go out and it starts to get cold, it is pretty amazing. It's like nothing you've ever been through.
Martha, I'm trying to remember. I think it was further back than 17, because I was at an American Chemical Society meeting with 10,000 other people in DC, and everybody just came outside and sat on steps of buildings where we were having talks and hotels and everything, and had their glasses. And so it was really kind of cool to have all these thousands of people, of chemists, sitting there watching the eclipse, and it was pretty exciting. It was a summery weather. I think it might have been August. Anyway, it was quite warm. It was really fun.
Well, you could see from the map that it's going to go straight over Rochester and straight over Buffalo.
Right.
And
Straight
it's a
over.
long one. Yeah, like 4 minutes. So
There
it's a long
there
one.
it would be it's 3 something, I think. It will be completely total. They're right at the center line.
Yeah.
If you know, on the other hand, all the people I know who are really big into eclipses, they're all going to Texas.
Oh, I've already been there.
Better
Because-
weather. Better
Because
weather.
they have better
opportunities.
weather. I mean, the problem is here that you've got to realize that there's the probability of it being clear is only 40% here.
Right.
But
But
Martha,
the last one in
mean?
Oregon, it's always dark and rainy in Oregon, and it was perfect that day. It
Yeah,
was
I
really
mean,
lovely.
if it's only 40%, but it is 40%.
Yeah.
But Martha, looking outside now, it's obviously not clear. If there were an eclipse right now, would we, and we'd still be aware of it, right?
It would get darker.
Yeah, but it wouldn't be very impressive.
No,
you
you'd
might
be
you might be able to see the shadow, but you wouldn't see the corona.
yeah. Yeah. I mean, you would know that there was an eclipse taking place. But
Right.
you would also feel really bummed out. Uh,
Especially if you didn't have your own picnic.
yeah, well, that's why I'm saying I think I'm going to go for it, but and I really hope it's clear. But I'm also going into it with the understanding that, first of all, I'm going to be very careful, and I'm going to be prepared for, even if I go on some little country road, there to be traffic somewhere on the way back. But I'm just going to be realistic that maybe it works and maybe it doesn't. And that it's Ithaca, and what can you do? But on the other hand, it's pretty exciting. Jane.
Charlie and I had the extraordinary experience of having a full solar eclipse when we were in his private airplane. And the experience was just unbelievable. You didn't know what was up and what was down, and just extraordinary. I don't think you could do that now, but it surely was extraordinary then.
Yeah, that must have been incredible.
It was.
Was it intentional?
Yes,
Yeah.
yes, we knew that it was going to be there. And so we were able to get up in the sky and, you know, we flew around a little and then bingo, it happened.
Yeah, that
And,
must be amazing.
It was.
No, I think it's worth it. This is it for us in this part of
Yeah.
the country. So, you know, but anyway, I'll keep you also up to date on comets and other things that I know are happening because I was actually pretty excited. I didn't know about these comets, but they could be interesting too. Robin?
When a number of years ago, was it called Hale-Bopp? Was that the name of the comet?
Yes, there was one.
It lasted for a number of nights, and I wanted to understand why. In other words, it didn't just, it was multiple nights that we would look for it.
No, sure. So what a comet is it's what we like to talk about them as dirty snowballs, but it's a relatively small object of some kilometers in size. And most of the time they sit far out in the solar system and they're icy and it's a mixture of ice and rock. And they sit out there and nothing happens, but they have very elliptical orbits that most of the time they're way out in the solar system, but occasionally they come into the solar system and come close to the sun, and then they go past the sun and zip out. So they're only near the sun and near us for a short period of time, but it is a period of months. But and the unpredictable part is we don't really know what anyone is made of and how long it's been out there and exactly what is going to happen when it gets close to the sun. The outer layers get heated up. And depending upon exactly what they're made of and what the trajectory is exactly, they light up, they get brighter, and they sometimes form a tail as they get heated up on the side that's close to the sun. So they form a tail, but the tail is always pointing away from the sun. So as they move in, the tail kind of sweeps around. Then we have the Earth moving around, and there's daylight and darkness and everything else. And you put all those together, and it's a little unpredictable, but sometimes if you have a comet that has a lot of stuff that makes a bright tail, and it's not doing it on the other side of the sun from the Earth, because of course we're moving around and it's moving in a different pattern, then you can get a comet that appears over a period of, well, it's tracked by telescopes for periods of months, but maybe for a week or so, it's in the right configuration that we see the tail and the tail is bright enough.
It was gorgeous. I remember that. It was just beautiful.
Yeah, I've seen a bunch, there have been a bunch of comets that have been around that you could see either with binoculars or if you were out in the countryside and it was pretty dark. And so the first one that's coming in April, it's sort of marginal. It's actually a periodic comet that comes by around every 71 years, which is kind of like Halley's Comet. It comes around every 76 years. But this other one is recently discovered by people doing surveys looking for undiscovered objects. And it's been sitting out there in the cold part of the solar system for a long time. And so it may have lots of stuff that will burn off. But we don't really know until it gets here. But that one will be in October. We'll keep an eye on that one.
Thank you.
And other than that, unfortunately, I'm sad to report, because I had to report this to my class too. We're entering a period which is lousy for planet observing. It just happens the planets are lined up with the sun and we can't see them, and it's not a good time. We have to wait a few months and then it will get interesting again. Okay, well, I'll get these slides out and I'll give you updates
Thank
as
you.
Thank you
the
so
months
much, Martha.
progress.
Thank
Yeah.
you.
Thank you,
Okay.
thank you.
Yes, thank you
Wonderful
so
as
much.
always.
you.
Let's hope
you.
for clear skies on April
Okay.
8th.
And no traffic.
No traffic. Okay. Bye-bye.
Bye.
Bye-bye.